All right, so the absolute value inequalities, before I explain this part up here to you, let's kind of just go over the steps. All right, that's the really important part that everyone forgets. They want to treat it like a regular equation, and that's just not what you do with the absolute value inequalities. In order to solve these, you need to be able to first isolate the absolute value bars. So get the bars alone. So if there's stuff outside the bars, like in number, not on this first page, on number 6 on your note page, so if you flip it over, if there's stuff outside of it, then you need to get rid of it. And you get rid of it just like the way you do a variable. So do the opposite of what's being done. Get rid of what's farther away first. So first you need to get the bars alone. Second, you're going to split it into 2 separate problems. Because absolute value, there's 2 separate answers for every time that you have x in absolute value bars. Like let's say I have the absolute value of x, and this I'll just make an equation. Let's say I have the absolute value of x equals 5. What are my possibilities for what x can be? So x could be positive 5, or x can be negative 5. Right? Because what do the absolute value bars tell you to do? It tells you to count how far away something is from 0. So how far away is 5 from 0? How far away is negative 5 from 0? 5 also. Another way people think of it is it makes whatever number is inside positive. So they think of it that way. 5, it's already positive, so it stays 5. Negative 5, make it positive, now it's 5. The only errors I see with kids thinking that way is if they see stuff in the absolute value bars, and don't write this down. Like in number 3, it's x minus 1. They think, oh, well, absolute value bars make stuff inside positive. So really it's x plus 1. All right, no. It has to be a single number in there before you decide to make that number positive. So that's why you need to get the absolute value bars alone first. And then you're going to split it up into 2 separate cases, which is what step 2 tells you to do. It says use the KISS method. So you're going to keep the first one. So just drop the bars, keep the first one. And then for the other one, you're going to switch. So since we're dealing with inequalities, you need to switch the sign, the inequality symbol, flip it, and then make whatever number it is the opposite sign. And we'll do an example so you know what that means. After you make the 2 separate problems, you solve them separately. Step 3. And then step 4 is to graph it on the number line. So let's look at example 1 right here. Are the absolute value bars alone on one side? So step 1's already done. Now we need to separate it into 2 separate problems. So the first one, using the KISS method, you keep it. It's going to be x less than 7. So just drop the bars. The other one, you switch. So you switch the sign. Now it's going to be greater than. And you make it negative. A negative 7. Notice that change. We switched the sign and the sign on the number. So that's a switch. Questions there? All right, and then if you want to highlight the keep it, that goes with this part. All right, and then normally you would solve both inequalities. They're not usually this easy. You would have to get x by itself, but they're already by themselves. So now just graph it. So I have a circle on what number? And for the 7, what direction does the arrow go, left or right? Left, because x is less than 7, so it should go like the number is less than 7. What about on the -7, open or closed circle? And then it needs to be numbers that are greater than that number, so left or right. And what type of statement is this when they go towards each other? And. Remember, they hold hands, right? So ands hold hands. So if you want to put in the middle here, and this is my solution. Graph and solve. Questions? All right, so that one is pretty easy. Let's look at ones that you actually have to do step 1, which is isolate the bars. So let's look at number 6. Questions on the first one now. All right, so looking at number 6 on your note sheet. Are these absolute value bars isolated? How do I get rid of this -1 that's next to it? Good, so do that on each side. On the left side, we just have the absolute value of x and 3, so x plus 3. Keep the sign the same, we didn't do anything that needs to flip it. What's 5 plus 1? Good. Now are the bars isolated? So then do step 2, which is good, the KISS method, right? So you have to break it into 2 separate problems. What's the first one going to be? Good, you keep it the same. All you're doing is removing the bars. The second one should be what? Greater than -6. Good. So that switch. There's 2 things to switch. All right. First one you keep it the same. Second one you switch the sign and make it negative. Good there? All right, then solve them separately. How do you get x by itself? Good. On the left, the 3's cancel. X is by itself. X is less than 3. We don't know what word goes in the middle until we graph it. So leave some space for and or. Over here, solve this one. Same thing, you need to subtract 3 on each side. And x is greater than what? -9. All right, and then graph it on the number line. I'll give you a little bit of time to graph it, make sure we're doing that part. Right. Some people think that the first step is to distribute, and it's not. So if you distribute it, don't do that again. All right, these aren't parentheses, they're absolute value bars. You have to first isolate them. That's what step 1 says. So just like you do a variable, get rid of what's farther from it. Would that be the 10 or the -3? How do you cancel that out? Good, so we're adding 3 to each side of the inequality symbol. All right, we have 10 absolute value bars, x minus 4, greater than what? 50. Now, are the bars by themselves? No. So keep going. How can I cancel out that 10? Good. All right. If the operator operation isn't written, what operation is implied? Multiplication. It'll tell you if it's 10 plus, or if it's 10 minus, or if it's 10 divided by. If it just says 10, that means multiplication. So opposite of multiplying by 10 would be good. On the left, the 10s cancel. So I have the bars by themselves now. On the right, also, do I need to flip the sign? No, you don't, because you divided a positive. So only when you divide a negative or multiply a negative. On the right, what's 50 divided by 10? 5. All right, good. So is step 1 complete now? Yes, we isolated the bars. Step 2 is to do what? This method, right? You have to make it 2 separate problems. The first one, what do? You keep it, just drop the bars, same sign and everything. The other one, what do? Good, you switch it. So instead of greater than, it's going to be, and instead of 5, it's going to be good. All right, so separate it into the 2 separate inequalities and solve them separately. So how do you get x by itself? Good, add 4 on each side. We get x, and I'll have to write it over here or something. X greater than what? 9. Try and squeeze it in here, but I also wrote it over there. Over here, add 4 on each side. And we get x less than what? -1. Leave some space in the middle to write the word once you graph it. If you should have graphed it, but what did you figure out? Is it an and or an or? That is correct. Because when you graph it, you have an open circle on the 9, and it goes to the right because x is greater than 9. You have an open circle on the -1, and it goes to the left because x is smaller than -1. And going in opposite directions, they look like paddles, they look like oars, you know it's an oar. Questions about that? All right, sorry that, hopefully while you were waiting for us to go over it, that you started the practice. If not, then start it now. You can knock out a few problems, and it's a mix of regular, compound, and absolute value.